Let me just go ahead and make that bigger. I'm just going to put that there. I know. I got to have a backdrop. All right, sweet. Let me make sure. All right, so I travel around the world taking photos of cats in different environments. And I'd like to say that all the cats are MIT licensed. So if you want to use them, they're all my intellectual property, but you can have access. Let me make sure. This presentation software, I call it the lolcat presentation software. It has to be at the right aspect ratio or else it freaks out sometimes. So hopefully it doesn't freak out on me. All right, so this is a fun talk because I don't get to talk about databases that much because I'm not really a database developer. I just pretend like I'm one, but that's the whole point of the talk. So let's say that you want to write a database. If you talk to any database developer that's working at like a quote-unquote database company and you say that you want to write it in JavaScript, they'll say, what? Do you mean, yeah, if you're Chris, who's awesome, like the Couch guys have been doing this for a long time, and they'll say it's awesome, but most people will probably say, did you mean Java? Like, are you sure that you meant JavaScript just now? So, but let's go down this dark path. Preface, it might be crazy, it might be a bad idea, but it's worth considering. So Node makes it possible, I think. And let's talk a little bit to set some ground understanding about what Node's good at and why it lends itself to this problem. So Node is a glue layer for kind of systems programming for evented I/O. You hear the word evented I/O, and a lot of people think that Node is for making web servers, and that's a side effect of what it's good at, but the core part of Node is for dealing with multiple I/O services. So an example is in the app that I work on with Michael. We have 2 databases, Redis and Couch, and we have like the Twitter API and the Facebook API and the Foursquare API and our caching stuff and a load balancer and web browsers and all sorts of crazy stuff. So there's all these different slow points that are all around the internet and running in people's pockets, and you have to deal with multiple I/O systems. And Node is a really awesome glue layer that we can have one process that handles everything on all of these I/O endpoints. And here's the thing, I/O is really, really slow in computer land time. If you're talking in the scale of computers and how they process time, like this is a total gloss over statistic, but generally speaking, databases are 100,000 times slower than memory for reads. So if you read something and it's cached in RAM, it'll be 100,000 times faster than if you have to go to disk. Because think about it, like you have to tell a thing that's spinning to like move an arm and read with lasers, and that lasers are fast, but there's a bunch of other slow stuff in there. So disk is really slow, I/O is slow, networks are slow. So it's good to establish that I/O and databases and networks and things are slow enough to do with JavaScript. JavaScript is fast enough to deal with them. And also with JavaScript now, you don't have to have a Unix beard to write a database. That's the thing. Like anybody here can write a database in JavaScript because Node makes it approachable. You don't have to like do a PhD in these things anymore. A lot of the problems have been solved. So there's this newer axiom in the Node community along these lines that's called jif-a-sniff. And it basically means JavaScript is fun, and so Node is fun. And it's a place for experimentation. If you look at the package manager and the growth over time, it's just totally exploding. People are going crazy with writing the stupidest crazy experiments in JavaScript. And the thing is, most Node modules are horrible. But that's a beautiful, beautiful thing. It means there's more failures per capita in JavaScript module land than any other package manager right now, which means people are trying more things, which means you also get a lot more successes. So jif-a-sniff is kind of the axiom that I think fits the community well because people aren't afraid to try weird things in Node land. There's a similar one in Ruby called Minaswan. Mats is nice, and so we are nice. Mats is the guy that started the Ruby language. And back in the early days of Ruby, when people get in an argument with each other, they would say, hey, remember, the person who created this language is really nice, so you guys should be nice too. And I think that with Node, you work on Node because it's fun. You work on it because, or things with Node because it's fun to do. You're not going to keep working on a project that's boring, that didn't go anywhere, but you still leave it on NPM and people still install it and ask you questions 6 months later. So it's this fertile ground right now. And then you have the haters. Haters are going to hate, right? You have people that come along and they're like, hey, event loops, whatever, you could do that in like the 1850s with this other programming language that you probably never heard of. And that's not the point. I think the point is that Node makes these problems approachable. You don't have to, again, you don't have to have a wealth of experience to get at it. Node brings these concepts that have been around forever up to the level of like weekend hack projects that you can kind of hash out quickly and see if it's a good idea. So let's also talk about what Node is bad at, just to make sure that the idea is not totally crazy here. So if you have totally CPU-bound operations, if all you're doing is like heavy computation, you should probably just write like a native algorithm for that. And luckily, though, most of the stuff, it's like kind of a high-level gloss-over thing, too. Most of the stuff in the database is not CPU-bound. So that's kind of like the core trade-off. Basically, to summarize, when the speed of your algorithm is a lot more important than the scalability, then there's like an impedance mismatch. But like Felix Geisendorfer, who set up the Wi-Fi here, I believe. And I don't know, is Felix in the room right now, by the way? Is Felix anywhere? His Wi-Fi is Transloaded. That's his company. It's node-powered. But he does the conference Wi-Fi. And he also wrote this awesome live coding streaming MySQL parser at NodeConf this year and demonstrated that you can write a streaming parser that's faster than a C streaming parser in JavaScript. So you can write JavaScript streaming parsers now because you can take advantage of like the GC that's really good in a lot of the VMs, and it's possible now to write really, really fast algorithms. And there was this awesome study done of just like pure raw math performance across a bunch of different VMs, and JavaScript was up at the very top of all of them, except for like matrix transformations or something. But nobody uses those anyway. So let's talk about like a database system. They're like these giant big things, but they're actually a few different components. So first of all, the most basic one is databases write stuff to disks. You have to go and tell the kernel to like put some data somewhere and actually like talk with that. And there's a ton of solutions to that. But in a lot of database systems, you don't get just the data to disk part. You also have a bunch of other stuff on top. So you also have like an indexing solution. So for instance, Couch uses JavaScript to index the database. So you give your data to Erlang, and it goes and puts it somewhere on the file system. And then you give it a JavaScript function to loop over everything. And you could have, like you put a bunch of JavaScript documents into it. They all have a name property. And then you write a JavaScript function to say, like, OK, now give me a view, like a materialized index on names, so I can sort the names in a list and get all the names that start with M. So it uses JS to iterate over the stuff it's already written. So it's kind of this hybrid solution. So you have storage and indexing. And then you have the final part, which is the actual like way that you access it, the thing that you give to a developer that they can use to actually get data out. And a lot of times this is a web server. I really like databases that have like REST and JSON. Sometimes it's like a binary protocol, like BSON and Mongo, or the Redis one, or like a SQL endpoint. So you have to have these three components. And here's the thing, like most databases are all of them. They're like a stack. And you have these vendors, like these big companies that are building like web frameworks and embedding them in these binaries that you install, and they're putting like everything in one giant solution. But if anybody's written a Node module here, they'll know that in Node, that's not the default like way of operating. When you approach a problem in Node, it's like, OK, how do you modularize it? How do you break it down into small components and have reusable modularization, like Unix philosophy style? So here's an example, like a case study. Let's talk about how Couch does it. I just happen to have a lot of experience with Couch. Shout out to Dale for having a CouchDB t-shirt on in the front row. Woo-woo! So Couch, oops, sorry, the the cat photo was the wrong size there. So Couch uses Erlang and JavaScript. And Erlang writes to disk. And Erlang implements the server. So if you open up an HTTP connection, it spawns an Erlang process. But then inside of Erlang, there's the SpiderMonkey VM. And it uses that to actually evaluate your JavaScript functions that you use to query the database. So it's crazy. It's like Erlang and JavaScript living together. And they collaborate to get your data out. You run into some issues with that. To cross the native process boundary is really slow. Foreign function invocation in general is slow. It's like why writing a parser in JavaScript is faster than writing it in C is because you don't have to go back and forth between JavaScript and C all the time. You can just stay in JavaScript the whole time. And same thing with Erlang to JavaScript. It's slow to jump between processes. So for certain problem sets, you don't want to have to run out to JavaScript. It's nice to be able to write your stuff in JavaScript because it's easier and JavaScript is fun, but it's not as fast in this case. So if the kernel of the idea that I'm proposing is basically why write the database writing to disk part in something that's not JavaScript. Do as much in JavaScript as possible, and you never have to do this inner process boundary craziness. And also, Node is like Erlang except fun. Erlang has some great ideas, but there's a reason Erlang doesn't have explosive module growth, just like NPM. This is not a negative Erlang slide. It's just a pro Jifasniff slide. Oopsies. So here's an approach that we can try out. So for the actual writing to disk part, we can use C or C++, and then we can use JavaScript to write to humans. Node is a first-class citizen, probably the best thing right now for writing streaming web servers that can accept many connections, that can do crazy stuff. Like I mentioned, you can integrate with a ton of different endpoints in one node process. So it makes sense to write the piece of your database stack that's sending data over the wire or transmitted it over HTTP and JSON or whatever. It makes sense to write that in Node because Node has awesome modules for it. If you're trying to have your database natively support WebSockets, for instance, there's a ton of WebSocket clients and servers to choose from in JavaScript, and they all perform really well and have active communities of support. So you get a lot by going with the thing that is the most popular for writing web servers these days. Cool. And so for the actual writing to data to disk part, I want to talk about LevelDB, which I think is pretty cool. And here's a quote from Ryan from the Node project. When we were discussing LevelDB, Google has solved the problem of writing data to disk. That's a high-level statement, but it's pretty true. It black boxes it sufficiently. LevelDB is written by this guy, Jeff Dean at Google, who, the way I understand it is people see Jeff Dean in the cafeteria and they go, oh my God, that's Jeff Dean. He exists. He's alive. He's some sort of living deity. And he's written he wrote the protocol buffer spec. He wrote Bigtable. He wrote a bunch of giant things. And LevelDB is this really tiny small database that all it does is it stores your data and that's it. You don't have to deal with the sleazy marketing company. Database vendors who have sleazy marketing companies, you know who you are. You don't have to, all it does is one thing, it's componentized. It's a C++ library. There's no high-level dynamic thing. There's no JavaScript API at all inside LevelDB. There's just a C++ library that stores your data on disk, gives you sorted lists. That's it, which is really nice. It's very modular. It basically gives you one-dimensional range queries. It's you put a bunch of keys put a bunch of random letters into it, and it'll give you an alphabetized list of letters that you can say, stream to me all the keys that start with the letter C, and you'll get a stream of data, and that's it. So it's cool because it's so simple. IndexedDB is in browsers now, and you could use LevelDB. Anybody running Chrome uses IndexedDB. Or IndexedDB is on top of LevelDB, and they wrote LevelDB for IndexedDB. So that's an HTML5 thing in browsers that you can play around with it. And the cool thing is that you can get range queries anywhere, not just in LevelDB, not just in browsers. Range queries are a very ubiquitous thing. It's just sorted lists that you can do fast reads and writes into. And I did a little experiment called PlumDB that uses LevelDB and Node to kind of implement a couch-style API and a couple hundred lines of Node using LevelDB to actually do the persistence. And it does streaming writes and reads, and it does replication. And you could check out PlumDB on GitHub as an example, but I'd love to see more experimentation in this space, basically. So I think modular databases are an awesome concept because you can roll your API, you can really integrate. You don't have to pick one giant monolithic solution, and you can integrate componentized solutions into your stack as you need them, have better granularity over which tool you're using to solve which job. And here's a quote from Isaac from the Node project that I got from a conversation he had with Jan, who's somewhere. Jan, he said this, Jan works on a couch project. Well, you know a thing or two about writing data to disks, and we've got functions for open, write, read, et cetera. He was talking about Node's file system module. So you could probably even use Node for the writing data to disk part, and I'd love to see experiments in that space. And so let's talk really quickly in the last couple of minutes about, now that we have 1D sorted range queries everywhere, like what can you do with that? Can you do a spatial index? There's this thing called geohash, which subdivides the world into many rectangles that you can put points into, and it reduces two-dimensional space by using Z curves or Hilbert like H curves, or like they look like N's. It reduces two-dimensional space into one-dimensional space by filling it with space-filling curves. It's crazy. It sounds really academic, but when you look at it on paper, it's really simple. You could also do this thing called a 1D R tree, which is what from PostGIS has a C implementation. You can also now in JavaScript have like first-class binary data support because of typed arrays. So cross-filter is this awesome thing. Kind of like, I like to describe it as Redis for browsers. And cross-filter is like basically just like a quick sort implementation that stores data in typed arrays, so you can fill up your memory with a bunch of data and slice it up a bunch of different ways and have really fast like data crunching stuff. Similar API to what you get with something like Redis, because it doesn't have to persist anything. And then the presentation that we'll hear about next is another angle here. It uses IndexedDB and other storage mechanisms to do couch in your browser, which is awesome. And so I'd love to see a point in time where I could write a JavaScript like persistence function that can run in Node, can run in the browser, can run anywhere JavaScript runs. And that's everything I had to talk about. Thank you very much. One last thing. I have a trivia question. If anybody knows, well, Dale wants to set up. So if anybody can name to me the on-disk journaling approach that LevelDB uses, if anybody knows the name of that, I have a trivia. Does anybody happen to know that what approach LevelDB uses for journaling its files? There's a fancy term for it. I have a special prize. No, close. Anybody? Nobody knows? All right. What's another trivia question? What's the current stable version of node.js? To Dominic, I have for you, you know, you can't get this anywhere else in the world. I have a fresh fish from the market. Come on up, Dominic.
Thanks for all the speakers. Good job, man. So there we go. Cats, a fish. Max Ogden, everyone. So right now we have Dale. First off, everyone is going really, really fast. This is very intentional, because the objective of this conference is really to blow you away with all the things that people are doing and inspire you to do it yourself.